I'm going to talk about how to do Agile, or how we do Agile, did Agile, and basically how we manage our architecture at the Port of Rotterdam in a constantly changing environment for the last 10 years. The Port of Rotterdam is the largest port, I think, in Europe. It was the largest port of the world, but there are now ports in Singapore and China, and they grow a lot. And, well, we still have a lot of numbers. You can see them, numbers. Not very interesting, but we are large. The project I'm working on, have been working on for 7 or 8 years, is called HaMIS, and it stands for the Harbour Master, that's the guy you see there, Management Information System. Basically, the Harbour Master is part of the Port of Rotterdam. The Port of Rotterdam is split into 2 separate entities. So first you have the commercial side. They just want as many ships in the harbor as possible and make money. The other part is the Harbour Master, which is part government, and they're responsible for safety. And those are 2 worlds that collide, because the safest thing is to not have any ships. The commercial part wants as many ships as possible. So that's why they split it up into 2 parts, and they're fighting against each other to make it profitable and safe. So what does our application do? Basically, everything you can imagine a harbor has to do. So we have a map where you can see all the vessels. We do inspections of vessels, log planning, which is actually not something we're doing for Rotterdam because we're open, we don't have any logs, but the Port of Amsterdam is also using our application, and they have huge logs that prohibit ships from entering the harbor, so you have to plan them in the logs. Ships sometimes have dangerous cargo, we have to inspect that, and we are responsible for safety, so a lot of stuff. A short history. You can see the timeline starts in 2004. The harbor was using an old system. It was called IVS, and there was a problem. It was running on old hardware, like really old hardware. Hardware wasn't being made anymore, you couldn't buy it. The only way we could get hardware in 2004 was Craigslist and eBay. And even that resource was running out. So it was time for the Port of Rotterdam to come up with a replacement. And big projects in the Netherlands need a government procurement. So we made one. And eventually 2 companies won, IBM and Ordina, and they started to make this application possible. So they put 15 architects on it, 1 developer. You need a developer, of course. And they were using IBM WebSphere Partner Gateway. You can kind of guess where this is going. This was 2008. And in 2009, the project was put on hold because the 15+ architects only managed to create 100+ pages of blueprints, no code. So that happened. Later that year, they tried to reboot the project, and they decided to do it in a different way. So we ditched all the architects, and we hired developers. Our focus was a working application, live in production, within the first sprint. And that's what we did. After the first sprint, we had something running in something we called production, and some user could actually do something in the application. Very basic, but that's where it all started. I wasn't at the team at that moment. I joined the team 11 sprints later. You can see, that's me. Oh, wait. Now you recognize me. You see the beard. That's me without a beard. That's me with a beard. You can also see the mentality of the project. The Port of Rotterdam has a very nice office. We're not in the office. We are in a shipping container, basically, put in another part of Rotterdam where the developers are doing their thing. The good thing is that gave us a lot of freedom. So we weren't on the corporate VPN. We could just download anything we'd like, build anything we'd like. We had total freedom. We were like cowboys. There was one part of the old information system, IVS, was a very big video wall, basically, consisting of a dozen screens. And only on that setup, we had performance issues. Not on a single screen, only on multiple screens. So what I did, I went to the media market. I bought a couple of video cards, put it in my machine, and I was testing with my own video wall, consisting of 4 randomly scavenged monitors. That's how we did it, and it worked. I actually managed to find a memory leak that was only present when we had like a lot of screens, a lot of tiles on the screen. Our project continued, and in Sprint 70, it was a memorable moment. We could turn off the old system. We have pictures of this moment. As you can see, there's actually one guy working. He is turning off the old system. And you can imagine this was an incredibly tense moment. We've been working for a couple of years. The old system was running for 10 plus years. Everyone was using it. This was the most exciting moment of our whole project. But if you read the body language of me and all the other people, it wasn't a very tense moment. And the reason is Agile. During that year, every single user was already migrated into our new system. No one was using the system. It was like, okay, we're going to turn it off now. Right now, I'm going to turn it off. Yeah, do it. No, but it's the old system. We're going to unplug it. Come on. There was no magic moment. It was the most underwhelming moment in the entire project. It was like everyone's bored, and can we get to the cake already? But it was important, because our new system completely replaced the old system. A couple of sprints later, sprint 100. More cake. The applications grew and grew. And a couple of sprints later, in 2016, we said, we need microservices. Why? We just need them. So that's what we did. A little bit about our team. Currently, we have multiple teams, 5 teams, working on the same code base, 100% cross-functional. This is what the application looks like, just so you get a feel for the application. You can see it is completely dockable. Every frame, you can dock it anywhere you like. It has an interactive map that shows every vessel in Rotterdam and in Amsterdam, and you can click on the vessel, see the information. We made this 100% in Swing. And the application was offline available, which was very important, because if you enter a ship, ships are huge cages of Faraday, so there's no connection whatsoever. So the application needed to be offline available. That's also why in 2008 we picked Swing and not a web framework. So you're here for technical stuff, so technical stuff. We're using Java Web Start to start a Swing application, which is made in Jite. Jite is a docking framework, and basically it's Swing panels. And the communication to our backend system was done using Hessian, which is a binary system. REST wasn't hot, so we picked Hessian. Now we're stuck. We had one single backend, which was running on Wildfly application server, Yable's application server, which turned into Wildfly application server. We had 2 nodes, which shared state, which was a horrible mistake we made, but yeah, we now have to live with it. And we are persisting everything in a single Oracle database using Hibernate. But that's not what I want to talk about today. I want to talk about the things we learned over the last 10 years. And for me, this is a very important project. I learned maybe 80% of the things I know about software development on this project. And I truly believe greenfield projects are cool, but you really learn how to do software development and software engineering and architecture if you're on a project that's been 7, 8, 9 years old. That's much, much harder. And sure, greenfield is cool. You can do Angular, React. I don't know what's hot currently. I don't know what's hot. Come on. React. Yeah, we're not doing that. So, some lessons. One of the first lessons, a rule we try to follow every time: experiment. Try something. If it's successful, great, you've learned something. If it's unsuccessful, even better, because you know the limitations. You know where it will fail. So it doesn't matter if it's good or not good. If the manager says, that's another failed experiment, explain him that a failed experiment is even better than a working experiment. Because if something seems like it will work, you might have not explored it fully, and you might not know the limits yet. So that's very variable. Another important thing is teaching is learning something the second time over. So if we learn something during our project, we share it, like code camps or sessions or knowledge sessions, and even just walk to a colleague, help him out, or if you have a problem, go to a colleague, explain your problem. Most of the time you don't even need an answer because explaining will solve your problem magically. Is that something, is that just me or, yeah? Another important thing, bureaucracy. I hate it. And Jim Collins said it very well. He said, bureaucracy is compensating for the incompetence and lack of discipline. That for me was like an eye-opener. Okay. It's also about trust. If you want to have freedom in your project, you need trust, obviously. And if people trust you, you will get freedom. They're interchangeable, very important. And this is something we had in our project a couple of years ago. They completely trusted us, we delivered every week, and we had all the freedom in the world. Now, they don't trust us as well as they used to. So our freedom is diminishing. Now they're trying to micromanage us. So trust and freedom, they're very tightly coupled. So another cool thing we learned is about the spiral of bureaucracy. There are a lot of spirals and waves, and we tend to see patterns in things that happen. So a project grows. You get more actors, you get more functionality. That's when complexity starts to creep in, obviously. That's a logical thing. Now you need to manage this complexity. You need to do something about it. So what do? You write it down. You write down rules, paperwork, procedures. For example, if you finish a piece of work, what do? You check the definition of done. Because everything that went wrong previously, you wrote it down in your definition of done. The piece of code you're about to deliver has to comply to all the rules. So this list grows and grows and grows. This is actually bureaucracy, because now you're no longer responsible. The piece of paper is responsible. And once your definition of done reaches 40 items, nobody will check those 40 items. It's just... But you're also not thinking about those 40 things because, well, it's on the paper, so I'm not responsible. The paper is now responsible. So this is where bureaucracy comes from. Agile. Like I said, we started this project in a very agile manner. But one thing we noticed very quickly was there's agile and there's agile. Capital A and lowercase a. We started doing Scrum, and it's a set of best practices. Best practices, not rules. So don't follow the rules, because there are no rules. There are best practices. It's things that worked at other companies that you could use, not should use. That's an entirely different thing. Always ask yourself, or once in every month, ask yourself, why are we doing this? Why are we doing a stand-up, for example? No, really, why are you doing a stand-up? We have teams with 3 or 4 people in it, just 3 or 4 cross-functional developers. I am constantly aware of everything my colleagues are doing. They're just 3 colleagues. I don't have to tell them every morning what I'm doing and what they're doing. We're constantly chatting on Slack, and basically we're pairing. I know what they're doing. I don't need to tell it every morning. So why am I doing a stand-up? Maybe we've grown and we've outgrown stand-ups. We're doing continuous stand-ups because we're continuously keeping each other up to date. So maybe we should stop doing stand-ups. But Roy, that's not Scrum. No, I know, but that works for us. So don't do Agile, be Agile. That's an entirely different thing. Another thing, we've, yeah, every project encounters, but especially projects that are 10 years old, technical debt. And for some reason, it's very hard to explain technical debt to non-technical people. They don't understand what technical debt is. Why did you make technical debt? No, we didn't make it. So I came across this picture, and for me, this was an eye-opener. If something is visible and it's positive, that's a feature. That's what we want. If it's visible but it's negative, that's a bug. Also very, very clear. The hard thing is labeling the invisible stuff. So if something is invisible and it's a positive thing, that's basically what we call architecture. Like, if it's all working and you can't really point it out, but it's working for us. And the invisible things that are negative, that's what we call technical debt. Like code smells or libraries that are not quite up to date or code that's just not completely relevant anymore. That's all technical debt. So it's invisible, negative stuff. Basically, that's it. And we noticed another spiral here in the last 10 years. So we measure our velocity. So we measure the story points we deliver every sprint, and it starts to go down because the complexity of your project increases. That's when you start to take shortcuts. Because you want to focus on functionality instead of quality and architecture. And when you do that, velocity decreases even more because you add more technical debt. You don't see it, but it's there. You'd start to take more shortcuts. And, well, your whole project ends down the drain. What we've done on numerous occasions was just stop everything, just spend 1 or 2 sprints entirely on fixing technical debt. This sounds like, yeah, why would you do that? But just to up the level of your project, I would recommend this. If you see technical debt increasing, just stop, fix it, and sure, it's hard to explain to a manager, but they'll understand, hopefully, if they trust you. What's architecture? If you look up Wikipedia, it says software architecture is about making fundamental structural choices which are costly to change once implemented. That's architecture. And it's true because Wikipedia says it. So, it has to be true. But the philosophy we had from the beginning was, if things are costly to change, you have to design for change. So, always have change in mind. Everything you make, assume it's going to change. And make it easy to change. Separate it from other pieces. Another thing we did was just-in-time architecture. So, find the last responsible moment to make a decision. So when's the right time to make a decision? Well, you can make decisions up front, but they are often made with limited knowledge. So you don't know what you're picking. There's obviously also too late. If you don't make a decision, the decision will be made for you, which is also not good. So find the last responsible moment to make a decision. And always do the simplest thing that could possibly work. Because maybe that solves your problem, and maybe you don't have to spend more money or more time making a better, more complicated thing. Just keep it simple. Also, software architecture. Is that like a document? No. For me, every line of code you write is part of your architecture. Because every line of code could suddenly change your program a lot. If you pull in new dependencies, it changes your architecture. If you call some module that you didn't call before, you're making your application much more complex. So every line of code is part of your architecture. Which also means, well, yeah, architecture is about code, not about documents. But this also means that everyone is responsible for architecture that writes code. You can't say one architecture is responsible, because then that architect should basically look at every line of code that's been written and judge about if it's correct or not. But that's silly. Like, everyone should have architecture in their mind writing code, because that's what you're doing. You're building something. So talking about the architects, as you remember, like I said before, we started with 15 architects, and we fired them, and we spared no one. We had 0 architects, and it became a shared responsibility. So how did we do this? Well, we started an architecture tribe. Every team has a tribe member, and they brainstorm, and they create an architecture vision, and they brainstorm about big changes. For example, do we go Spring Boot, or do we go Java EE for the next, like the vision. Those team members convinced the product owner to prioritize depth and technical stories, because you always have technical depth stories, technical stories. You have to prioritize them. We just need to convince the product owner, and well, if it's important enough, he'll be convinced you get the time to do this. We also have code camp sessions where we spread the knowledge about architecture and we spread the vision. But who organizes those tribe meetings and the code camps? And what if there's a stalemate and the team members can't agree? And who's responsible for spreading the vision? And who handles all the questions from outside your project? #shitfilter. Okay, actually we do need someone for this, so let's call him or her the architect. But it's not the kind of architect that dictates, it's a serving architect. So that's a modern servant architect. He or she should act like glue between the teams. The teams are doing their thing, the architect keeps an overall view and talks to all the teams. He or she is free to think about unrelated current issues. So you're not deep in some epic on functionality, building something for a certain user. He or she is free to think about the bigger picture. That's important. The architect is also a kind of asynchronous buffer between the teams. If team A wants to do something and they want to bother team B with it, well, don't go to team B, they're focused, come to, well, me in this case, and I'll ask them at an appropriate time. Or I'll answer the question for you if I can. The architect's also a buffer between management and the teams. Management should never go to a team and ask technical questions or why did you know? You come to me. Basically, #shitfilter. I'm the architect, I'm the shitfilter. Self-organizing teams, also a thing we learned. So our teams are self-organizing. If you want to do something, great. Great. If you want something, you can make it happen. You have all the freedom. If you decide you need a new monitor, well, go ahead and buy one. If your team decides you need a new team member, sure, we'll hire someone. If your team decides you need a new test application, okay, we'll buy that test application for you. You organize it. Shared responsibility often means no responsibility. If you see a piece of code that's crap, it's like, oh, that's really crap. Yeah, but it's not my responsibility to fix this. It's our responsibility to fix it. It's also your responsibility and your responsibility. So, yeah, maybe someone else will see it and fix it. It's not my responsibility. And this happens in a lot of things. We've seen this a lot. Everywhere we have shared responsibility, often means no responsibility. So for architecture, I'm responsible. If things are crap, it's my mistake, come to me. I'll make sure we get it on the backlog and get it fixed. Like I said, microservices. We had one front-end application, one back-end application. But we had a couple of problems. First was the deployment cycle. It started to take a long time. So instead of just hitting deploy, it would take a couple of hours to update everything. We'd have downtime of maybe half an hour. And if you want to do Agile and release every 2 weeks, what we did, a half-hour downtime was not manageable anymore. So we needed to fix this. Also, we were stuck with old technology. We had a huge backend, and every time we wanted to update something, we needed to update the entire thing. So if we wanted to go from Spring 2 to Spring 3, we needed to update the entire application. You can't just update a couple of services and leave the others untouched. No, we needed to update the entire application. This was cumbersome. Another thing was HaMIS was no longer sexy. This sounds like a shit argument, but it's not. We were doing Swing development, and I went to my colleagues, we need another developer, come join our project. They said, well, hell no, I don't want to do Swing. So all the good developers would rather do React or Angular, or they don't want to do Swing. So this sounds like a shit argument, but it's not. It's very important. If you want to have proper, good, enthusiastic developers, give them something cool to work with. So our design changed. Initially, we had a 3-tier design, basically front-end, service, and persistence. Then we went to what's called a hexagonal design. If you don't know, does anyone know what a hexagonal design kind of is? A couple of hands. I'll go into that. And finally, we went to microservices. So if you have a hexagonal design, what you say is that the functionality is basically in the middle, and everything that's on the outside is connecting to the outside world. So data persistence and UIs and REST calls to Angular and REST calls to other applications, they're all on the outside, on connectors. And your business logic, the internal things, are inside. Also, the things are divided into like pizza slices. So functionality-wise, we had inspections, for example, which is an entire functional slice of our application, was really well-defined in a pizza slice. And it had, well, there's one blue arrow, so I don't know, maybe it had one REST service that provided inspection data or something. So we wanted to go to microservices, so how do we make a smooth transition? And for us, that was very easy. In the front end, we decided to replace the Swing panels with JX browser panels, and in those panels, we would just run Angular. So every new panel could be made as an Angular project running on NGINX, and it would still be visible inside our application, just as usual, but we're using cool technology. So we solved one problem. In the backend, we started to cut pieces from a monolith, and we placed them in microservices. And the database, we just left it as is, but we separated out functionally. So every microservice has its own schema, and all the data is just for that single microservice. But we had no reason yet to, well, we already paid for Oracle licenses, so we have the Oracle database. It's just all in one database, but it's separated schema-wise functionally. Right now, we have 20+ backend microservices, and they're all different flavors. A lot of them are Spring Boot now. We have some Wildfly Swarm microservices, and some are just running an entire Wildfly application server. So they're not that micro, but they're services. 10+, which is 20+ by now Angular projects running an NGINX, which is a web server, a file server, running Angular 2. We have one leftover backend, which isn't finished yet, and one leftover Swing application, which also is still there. And like you saw, we're using Spring Boot and Wildfly Swarm, and teams are able to pick their own technology, which is good because you have a lot of freedom. If you want to do React, the next panel you make in React. You have all the creativity, and you're using state-of-the-art technology. There's a downside, obviously. We've noticed that those microservices deteriorate much faster. Before, we had one backend. If we decided to go from Spring 2 to Spring 3, we would touch every line of code and update it to Spring 3. Right now, we have Angular 1 applications, Angular 2 applications, Wildfly Swarm, old version, Wildfly Swarm, new version, Spring Boot 2, Spring Boot 1. We have every piece of flavor, and we're not updating them, because if you're working functionally on one thing, you don't want it, and you want to update that because you're working on it, just leave the others to be. They're working fine. If you have to touch them, maybe then upgrade them, if you have to touch them and they're like really old, replace them because they're very small. Don't know if that's a good thing or a bad thing, but yeah, it might cost us more. Some more drawbacks we noticed. We are duplicating more code. Because now, if you write something in Spring Boot and you also write it in Java EE, maybe it does the same thing, but they're not interchangeable, so you duplicate it. Or if you're doing one thing in one microservice and one thing in another microservice, you could obviously make a utility class and share it, but then the versions will. So we just copy the code and have it separated. This is easier because if you change your microservice, you can change the code with it. But yeah, if you fix a bug in one piece of duplicated code, you're not fixing it in the other. So another drawback of the microservices. Also, monitoring is much harder. Before, the backend was running or it was broken. And most of the time it was running and it was doing fine. Right now we have 30 pieces that could be running or not running or staging or maybe it's much harder to monitor. Don't underestimate this. If you're thinking about using microservices, this is very hard to do well. And you need to design every single system to handle situations that you're maybe not thinking about. Because if the database is down, your microservice can't access the database. It has to do something about the calls. So what do? You have to, a lot of hard things to think about. Another thing we noticed was that our code style is diverging. Some teams are doing Spring Boot, and they're doing, they're writing pieces of code in their own way. Another team is doing other microservices, maybe also Spring Boot, but they're fixing their problems in a different way. They stop communicating with each other because they aren't seeing each other's code anymore. Because every team has a couple of microservices that are their microservices, and they're not touching the other microservices. So this is something we noticed. The teams just have a hard time learning from each other because they're not in the same code base anymore. Another thing we learned was saving the best for last. So when we break up our monolith, we start easy. We started with, I don't know, I think inspections, because that was already functionally very separated from all the other parts of our application. We pulled it apart, made a microservice of it, and we took the next thing. We pulled it apart, and we worked our way down. So that sounds good, right? That sounds like a proper approach. Everything we do in our application, which is for the Port of Rotterdam, has to do with ships. So the thing that connects everything to everything is ships, and the journey the ships are making, the stops they're making along the way. This is our core business. So that's the hardest thing to pull apart. So we just leave it as the last part, because if everything else is pulled apart, what we end up with is the ship part, which we can't really, we don't know what to do with it, so we'll just leave it as the last thing, and if it's the last thing, it's already a microservice. That also sounds like a good tactic, but actually it's not, because every time we pull something apart, we create a new interface that talks about ships. Right now, the backend has like 30 different ways to communicate about ships, which is horrible, because we'll end up with a microservice that has like, maybe in the end, 50 different ways to talk about ships. A better way would be, and that's what we're doing right now, is to define an API for the ships. That API doesn't have to be a separate microservice yet. It can be an internal API. So we're already thinking about the design of the final microservice, but it's still in the backend. We haven't pulled it apart yet, but we're pulling it apart by creating an extra API and defining basically what you can ask and what you can't ask about ships. So don't just assume you'll end up with a microservice, just create APIs along the way. Team dynamics. Who here is familiar with Conway's law? Yeah, so it says that organizations which design systems, they tend to make systems that are very similar to that organization's communication structure. For example, an example I use a lot is banks. Banks are usually formal. They're very strict. I know there are some examples in the Netherlands that aren't, but they tend to use a lot of paperwork, and they also tend to use, for example, SOAP, because that's very strict. You define everything, and that's basically means, yeah, there you can see that the communication structure inside these organizations also cause, well, maybe they prefer SOAP over maybe JSON, because that mirrors how they communicate inside the bank itself. We've noticed something different, like the inverse of Conway's law. Actually, it's my law. Organizations which radically change their system design should also expect changes in communication structure. Before, we had one big monolith. Everyone was working on the same code. If the backend was broken, everyone felt it. Everyone would jump in and would fix it. Right now, we changed into microservices. So team A has a couple of microservices, team B has a couple of microservices. If one microservice of team B is broken or is crappy, team A just continues as they were. They no longer feel responsible for the entire product we're making, just their own microservice. And you see this in a lot of things. You see it in communication, you see it in team dynamics, in comradeship. Before, we would go to dinner with a couple of times a month with the entire project, and now a team goes to dinner, and another team goes to dinner, and the architect is left at home. So I hate this, but this was something we didn't expect. We were really surprised by this, but when you think about it, it's very logical. But so if you're thinking about doing microservices, expect your team dynamic to change. A couple of other things we learned. Who here is familiar with cargo code? So this sounds like a fun story, but I'll pull it back into IT. What you see here is a tribe in Melanesia, which is somewhere north of Australia, a small island, and they have indigenous people that never saw Westerners. Never. So they were living in the bushes, doing their thing, and suddenly World War II broke out. So what happened? Planes started to fly by. They saw iron birds in the sky. And then another amazing thing happened. Those iron birds started to land on their island. They'd never seen anything like that. They'd never seen a t-shirt. They'd never seen a spoon. They'd never seen metal. And suddenly, this iron bird landed, and it gave goods and presents. World War II stopped, and the planes disappeared. The people were left alone. The gifts weren't coming. The big metal planes left, the iron birds. So what do? You lure them back. So you build runways, and you build planes, because if there are planes, like a lock ain't, if you have planes, planes will come, right? That's cargo code. How does this relate to IT? Well, it's something we do a lot, but we're idiots, basically. Spotify does X. I'm not, Spotify does a lot of things, but Spotify is successful. We don't do X. If we do X, we will be successful. Yeah, that's not how it works, right? So this is actually a very important thing. So we wanted to do microservices because microservices are awesome. And now we're doing microservices, and we're not that awesome yet. Or maybe we will never be, but it's also related to survivorship bias. 2 more fun stories, and I'll bring them back to IT. I've got 2 kids, and they go to my grandparents a lot, at least 1 day a week, and my grandparents always have an old box with toys, and every time I'm there, they say, look at these wooden toys. Those are indestructible. They are 50 years old. The kids are still playing with it. Right now, toys are crappy. You buy something, it's broken in 2 weeks, and The toys were much better in our age. Like, that's every grandparent says this, right? But that's not true. 60 years ago, there were a lot of crappy toys. They broke and they threw it away. But they don't see those toys anymore. They only see the toys that survived. I'm pretty sure I've got toys for my kids right now that will be around 50 years from now. I don't know which one it is, and I've got Lucas, so maybe the toys won't be around 50 years later. But that's survivorship bias. You only see the things that survived, so you think everything survived. But you forgot a lot. You forgot all the broken toys. Another World War II story. There was a plane, and the plane got a new engine. And a new engine meant they could add armor to that plane. So what did they do? They noted every time a plane landed, they would note down where the plane was hit. And this was the image that they created. They took this image and they went to the airplane manufacturer, and they said, well, our planes get hit a lot here and around the wings, so that's where we need to put the armor. The airplane builder said, that's not what we're going to do. We're going to put armor here, and here, and here, and here. The general was furious. Why aren't they listening to me? But then the airplane builder explained, all these planes landed. The planes that got shot here, here, and here, and here are on the bottom of the Atlantic. Which is also a case of survivorship bias. Two fun stories, but how does this relate to IT? Well, today we're at the conference, and I've heard 3 talks about successful projects doing microservices. 2 points. 1, nobody talks about failed projects using microservices. And the second is, there are also a lot of successful projects not doing microservices, but they're not hip, so they are not accepted. Keep that in mind. Back to the timeline. We are now in the present. It says sprint 181, but that's not true. We're close to 200 right now. We still have problems, a lot of them. We have big, scary things that are left unfinished. So we're still at Java 8, for example. I was doing Java 9 yesterday, had to revert it. We're still using Swing. So we still have one big Swing application with panels that are in Angular. But there's no path that will take us away from Swing yet. We're working on that, but we're not there yet. Our backend is still running Wildfly 9. And I think they're currently at 11 or something, but yeah, we just can't be bothered to do that. And like I said, we don't have a vision about the front end of our product or products. So should we go make a web application? Should we ditch the entire application? The users aren't satisfied. Like, what should we do? There's also a big discussion at our company about safe and less. Who here knows safe and less? Who here loves safe? Oh. Who here loves less? Oh. What do you love? No hands whatsoever. Come on. Waterfall? No? Scrum? Scrum, okay. Actually, if you read about the history of less, a lot of things that are currently described in less is what we were doing 10 years ago when we started doing this project. Our project is also used as an example in a lot of less trainings. So Bas Vodde and Victor Grigic and Greg Larman, the inventors of less, they wrote less based on a lot of what do you call it? Best practices. And a lot of those best practices came from our project. For example, we had budget for 2 years. And in these 2 years, we could do anything. We had total trust, and we had freedom. And in the, basically, we promised that something would be finished 2 years from now. How we got there, and in the end, we made something entirely different, but they were satisfied. We had trust, we had freedom. But now SAFe came in. And safe is, for me, like the manager's Agile. And that's not a good thing. Because currently, our organization, the Port of Rotterdam, is adopting safe, but they're making their own version of safe, which is even better, of course. And right now, what we're experiencing is they're doing safe, they are Agile. We also claim to be Agile for some reason they don't understand, because we're not doing safe. So they want to force safe on us. For example, we now have 2-month budgets in which we only focus on one specific task, which means we're ditching all the other tasks, and we're not paying attention to them. When we used to have budget for 2-3 years, like a big budget, we could fix anything if we said, oh, this is a good moment to update from Spring 2 to Spring 3. We did it. Right now, if you have budget for 1 month or 2 months, and we say, no, this is a good moment to update Spring. No, you can't do that. You can ask for budget to update Spring 2 to Spring 3. But why are you asking for another technical thing? Make a good application. Why do you need money for that? We used to put a lot of money into those things, but it wasn't visible, and they didn't care. They trusted us. Now, bureaucracy, we need to write everything down. We need to apply for funding for each and every increment, because that's Agile. But it's not. It's the opposite of Agile. But yeah, so like I said, safe killed our Agile, but that's like a story for another day. In the end, we'll be okay. We'll keep evolving, we'll survive. The application is being used by 450 users. It doesn't disappear from one day to another, even though they're complaining they want the old IVS system back. Happened yesterday. So, this is not a story about successful microservices transitions, about successful Agile projects. It's just a story about our project and the problems we've encountered and the things we fixed. And I don't think we have those stories enough at conferences. So my question to you is, next year, you present, I'll be sitting there, I'll be listening to your answers and solutions, I can learn from you. This was my story. If you have any questions for me, ask. Yep, Peter.
How do you choose the architect?
How do you choose the architect? Well, we had one good architect. His name was Victor Grigic. For me, that's like, if you ever get the chance to meet him or do one of his courses, he's currently in Hong Kong, so it's a nice visit. Go meet him, because for me, that's my idol. I learned everything from Victor. He left, he went to Hong Kong, so he was no longer part of our project, and we had a huge gap. Nobody wanted to do that, because architect in our project means you're a shit filter. So every time we asked, one person from the team would stand up and say, okay, I'll be the architect. They lasted maybe 6 months to a year, then they left because they were sick and tired of being a shit filter. It's not a fun job. So the last time our architect left, we had a new vacancy, so we asked around and we started looking, and we couldn't find anyone that wanted to be the modern servant architect type. And I said no like 20 times. Oh, you want to be your architect? Well, I don't think you can try. They tried for a couple of weeks, and he or she doesn't cut it. So in the end, I decided I could do this. I am the perfect shit filter. And that's what I've been doing now for a year, and I'm not thinking about leaving yet. So how do you pick an architect? Well, you have to find someone that wants to be the shit filter, basically, and knows about architecture and has a feel about architecture. And yep.
Do you still write code?
Do I still write code? Sometimes. I need it. As much as I can. But most of the time, I don't do the functional stuff. So the functional stories often go to a team, and I tend to do proof of concepts. For example, Java 9, I do the first proof of concept, maybe with a couple of team members helping me. And if it works, and it works on staging and production, then I can ask the teams to do the same, and they can update their microservices to use Java 9 or Java 10. So that kind of programming, luckily, I can still do. Yeah. Why are the users not happy anymore? Well, I think, and that's my personal opinion, and not everyone agrees, that it's all because of budgeting. I was talking to a user yesterday, and she said, we've got one pop-up screen. We created that 3 years ago, and she's so unhappy with it. And every time she meets our product owner, she tells him that she's very unhappy with it. But we're doing other functional stuff. We only have budget for one thing, 2 months. We have to do that. That screen, for some reason, we never get around to fixing that, because when we had budget for 2, 3, 4 years, we could just fix it because that would make our users happy. Like, that's for us the most important thing. But right now, it stops somewhere. It stops somewhere between the user and our product owner and budget. Like, there, things go down the drain. And yeah, that's a really big problem. And that's something we actually need to fix. And we have an emergency meeting at 10, which is right now, to attend this and to try to find the cause of this. Yeah. Question? Yeah. So the question is, how do you keep balance between the short-term stuff and the long-term technical debt stuff? So our tactic to convince managers is basically, if we feel that something is technical debt and we need to fix it, we need to convince that product owner, and if we convince the product owner, he will convince the managers that it's necessary. And that's up to us, basically. If we feel that we are going to be faster or better or more agile if we do Spring Boot applications, and we need to update one of our Swarm applications to Spring Boot, we need to convey this to the product owner, and we need to convince him or her that it's very important to make this change. We need to sell this. And that's where we saw that team members were no longer feeling that responsibility, and now it's my responsibility. So if a team member notices something, they come to me, and it's my responsibility to convince the product owner to do that. And because I'm not working on the functional short-term stuff anymore, I can look at the bigger picture and the longer-term stuff and basically spar with the product owner. Does that kind of answer your question? Yep. More questions? Yep.
You mentioned in your presentation that code style started diverging between teams. I wonder if you consider that a problem, and if so, do you have solutions?
Yes, I mentioned that code style is diverging between teams. One, is that actually a problem? And two, what could you do about it? I think it's a problem because I've noticed that certain teams are fixing problems that other teams are still having. So, for example, certain settings that have to do with MQ that better handles outage. One team fixes it, the other team isn't aware of the fix. That's a problem. And how do we fix it? Well, we constantly encourage people to do short presentations during code camps. If you think you found something that's interesting for other teams, share it. Talk about it, do a small presentation, maybe even 5 minutes, show the code, show how it works, and share this. And that's the only way to properly solve this. But if people are doing like functional things and they're called because there's a code camp, they don't want to, that's also my responsibility. I feel that's my responsibility to go to people, to ask them, did you do something cool today? Or what's this? What are you working on? Can you share that? Can you share that with all the people in the code camp? And for us, that's very important. And also, I feel that's my responsibility as the architect to make sure that the knowledge is spread. Other questions? All the way in the back. I can hardly. Can you speak up?
Did you do 2 years ago about microservices and now?
Okay, that's a tough one. The question is, if you knew 2 years ago about the problems you're having right now with the microservices and the transition, would you do it again? I think I would, because if we were still having one backend and one swing front end, we would have no developers left. And that's a bigger problem. If we didn't do this transition, I think right now we would have an entire new project. The entire project would be scrapped, and we would make a new application. And I'm not saying that's a bad thing. That could be a good thing. We're actually thinking about scrapping the entire front end, just leaving the microservices backend and making an entire new front end for it. But no, I think it's very valuable that we did this. And yeah, I still think it's a good choice. But it's a hard one. Yep, Peter. What's the expected lifetime of the current system? Well, this is actually something that we never discuss. So this is a very, very topic we're currently touching, because I think the front end we're having is end of life. I'd rather have it replaced now than in 1 or 2 years. So I'm battling and working towards just scrapping that and creating a new front end. The microservices, on the other hand, they keep evolving, and they're working fine, and they're working very well for us. So I think those are, if you would plot it on a graph, they're just, I think they could possibly 10, 15, 20 years. It depends on how you keep it up to date, of course. You need to put in the effort to keep it up to date, but they have a future. The front end, not so much. Other questions, or coffee, or? Oh, he says it's the end. So if you have questions, come to me.